Last week I set up all the cameras for my scene to play through a couple shots. I'll go ahead and play that again just to recap. And here I've added a third shot to the end just to give us a third angle to work with. So now that the scene is set up, all we need to do is add lighting, and then we can render it out with the Arnold render engine. So what is Arnold? Arnold is a render engine built into Maya which utilizes ray tracing to generate a photorealistic image. So put simply, the way that ray tracing works is our camera shoots out a bunch of little lines or rays for each pixel that will make up your image. And those rays shoot out into your scene and hit all the surfaces that your camera sees. And then from each of those points, it takes in what objects are around it, what lights are around it, and it calculates exactly how that pixel should be lit in a photorealistic way. So to render something out with Arnold, we can go up here to the Arnold menu and just hit render. And that will pop up this pop-up here, which acts as sort of a window into the scene that we're rendering. But when you first open it up, it's going to be all black. This is because we haven't added any lights to the scene yet. So because there are no lights to create light bounces, there is nothing to render. So before we can start rendering our scene, we need to dip into lighting. So I'm going to close this for now, and let's start adding some lights. So in Maya, there are two kinds of lights. There are lights which are built into Maya and come standard with it and have been there since the dawn of time. And then there are Arnold lights, which were introduced to Maya specifically with the introduction of the Arnold render engine. So to add a light, the quickest way is to use your shelves. And there's two places to find these lights, the Arnold shelf and the rendering shelf. The rendering shelf is where you'll find all the lights that are built into Maya from the beginning. And then the Arnold shelf is where you'll find all the lights that were introduced with the introduction of Arnold. If you're theoretically using a different render engine, such as RenderMan, then these Arnold lights would not work with RenderMan. So coming back over here to the rendering shelf, we're not going to go through all these, but we'll go through a couple of the essentials. So first up is the tried and true point light. And I'm going to press F to focus in on that. And a point light is simply a point in space that emits light. It is as simple as that, no extra fancy features to it. And right now it doesn't look like much, but we can preview what the light will actually do in our scene if we turn on our lighting previews in the viewport. To do that, I'm going to go up here and click this light bulb to preview the lights. And then next to it, I'm going to press this button to turn on shadows. And if I zoom out, you can see a very, very rough preview of what the light will look like in my scene. And then I'm going to turn on my textures too, just for an additional preview of that light. So now that my light is in the scene, I can go over to my attributes editor and I can start changing some of these settings with that light. So I could change the color, maybe make it a sort of a bluish teal. And then if I want to make it brighter, there are two sliders involved with that. There is the intensity, which increases the brightness of my light linearly. And over here in the Arnold menu, I have exposure, which increases the brightness exponentially. Now you notice that the exposure isn't changing in this preview, and that is because the exposure is exclusive to Arnold. So when you're working with the lights, the viewport isn't very reliable as far as a way to see what your lights are doing. The better way to look at your lights is to do a test render. So now I've opened my render, but there's not a lot to see here. It's still black. That's because I've left my exposure very, very low. For all the lights that are built into Maya, they have this Arnold tab here. And generally speaking, these lights are very, very dim until you turn up the exposure. And you might need to turn the exposure up very high. The slider by default goes up to 5. And you'll see now my light starts to come in. You can turn up the intensity too. But that will only really get you so far. Generally, you want to be using the exposure more. that'll get you quicker results. So now I'm going to crank up the exposure to 15. And now we really see that light coming in. I'll drop my intensity back down to 1. And I can change my view if I rotate my perspective camera. And you can even zoom in and out of your preview image with this scroll wheel, and all the same controls that you would normally use in your 3D viewport work for this 2D preview. So holding Alt and pressing middle mouse lets you pan around as well. Now, rendering this image out is very, very resource intensive, and you'll find that you won't be able to get a lot of work done while this is actively rendering. And every time I try to change anything, it slows down my computer a lot. So the best course of action is to stop your renders when you make changes. And I can go over here, plug in some new numbers, maybe make this red. And then I'm going to hit this button again to start a new render. So that's point lights. Let's take a look at another kind of light. And every time you change what lights you have in the scene, you want to close your render cam, just because you can get some errors in your test renders, which won't be resolved until you reopen the render view. So next up, I'm going to create a directional light. I'm going to click that. And once again, we'll go to Arnold, jump the exposure, make that 12. I'll jump the intensity just so I can see it in the preview. Now, a directional light doesn't work from any specific spot. Rather, it is a generalized light that beams down upon your scene, coming from the sky, pointed in the direction of this gizmo, whichever direction you point it in. So this is a really good way to set up just a very simple single light source that lights up your whole scene very quickly. I'm going to go into color. Just give it a little bit of a color there. And hit render. And that's super blown out. So I'm going to drop my exposure. Because the directional light doesn't come from any specific point, it's kind of covering the whole scene with the same brightness. It's a lot easier to blow out your scene. So you can be a lot more reserved with your exposure and intensity when working with a directional light. So that's a directional light. Next, let's take a look at spotlights. So I'm going to delete the directional light, turn off my render view, and I'm going to click this to add a spotlight. And you can see in the preview, it originates from a single point in space, just like a point light does, but it emanates out in a cone shape rather than in all directions. So I'm going to give it exposure of, let's say, 10. Give it a new color. Say green this time. And let's render it in Arnold. So while that's rendering, I can go ahead and play with some of the settings for this. So you can adjust the width of the cone with cone angle. Make it much wider. And then with both penumbra angle and drop off, you can change the softness of the edges. So penumbra angle mainly deals with what's very close to the edge, whereas drop off will soften the whole thing until you get to the very center. So this is very good for like street lights and flashlights and that sort of directional light that comes from a specific light source that's not just like the sun. So there's the big three Maya lights that I wanted to show you. Next, let's take a look at some Arnold lights. So I'm going to close my render view, delete that spotlight. I'm going to go over to the Arnold tab. And here I'm going to start by creating an area light. So an area light works very much like a spotlight in that it is originating from a point in space and goes in a specific direction. But the cool thing about an area light is that it covers an area rather than coming from a single point. So I'm going to crank up the intensity and the exposure. And what's nice about working with the Arnold lights is that they actually do show up in the viewport preview, as opposed to the Maya lights, which struggled with the exposure. So this is going to look a bit more like our Arnold render. And if I bring this light, just pause the render for a second. I bring this light really, really close to the ground, and then expand it. You can see how that light is emanating in a square. You can grow it this way. Hit render. So the light comes out from the square. And I can change some of these settings to make the area a bit rounder and soften the edges, kind of like drop off on the spotlight. So you might use this for like a window or a fluorescent light in a scene. Especially if I pull it up like this, it lights up one area very well while leaving the rest untouched. The larger you scale it, the higher you have to turn up the exposure and intensity. So I'm gonna make this 15 to compensate for it being larger. And now it's pretty bright, so I could go back in, scale it up even more, raise it up. And it's still pretty bright, but you get the idea. I'm gonna go ahead and delete that so we can move on to the next light. So the next light we're going to create is called a mesh light, and that is this icon right here. But before we can create a mesh light, we need to select a mesh that will act as the base shape for that light. So I'm going to go ahead and momentarily turn off our light preview, and I'm going to select this sphere right here in the skull's eye socket. I'm going to go up here and click mesh light. And what that's done is it has hidden my mesh and added a copy of that mesh which acts as a light source. So I'm going to turn on my light preview again, and I'm going to crank up the intensity and the exposure. Looks like for mesh light, it doesn't want to preview our lights in the viewport. That's okay, so I can just go to Arnold, and from there I can see the light being rendered. So from there you can see that my light source is now just that entire sphere. Now let's say that I wanted to have an object as a light source, but I didn't want to actually hide the object itself. In your attribute editor, you can simply select show original mesh, and that object will appear again. And that's really great, but it doesn't really look like the object is actually emanating light. So to create that effect, there's one more thing I have to do, and that's actually edit the material of the object. So I'm going to pause my render. I'm going to open up my hyper shade, drag that in. Now I have a material set up for this. It's called glow ball. And under glow ball, I'm going to scroll down to emission. Pull that up. Under color, I'm going to eyedropper that color in my preview. I'm going to turn the weight up. So what emission does is it basically makes the texture appear to be glowing. And it emits a little bit of light, but not very much. So that's why we need to be using a mesh light if we want to emit a lot of light. And I'm going to set my weight to about, let's say 3. All right, I'm going to close that and hit render. And now that ball looks a bit more like it's actually emanating the light. I'm still not quite happy enough with that, so open the hyper shade again. More 4.5. There we go. And one more touch. Let's go back to the light. And then if we open up our outliner, we can see under the sphere that I've made it into a mesh light, the light is actually attached to that original geometry. So if I want to change the light settings, I select the light, which is parented under the sphere. And then let's go ahead and give this a new color. I'll go ahead and eyedrop the color that's on the sphere. And I'll hit play. And now the light matches the color that's emanating from the ball. It's a little bit bright, so I'm going to drop down that exposure again, and that intensity. And this is a back and forth you'll probably need to do if you have a glowing object to really make it look like it's the object itself that's emanating light. So that might just take a little while. There we go. I think I'm happy with that. And you'll notice, because that material was shared between multiple spheres in my scene, you can actually see what the effect of that mesh light is. So you can see in my render that the emissive material does emit some light, but it's not nearly as much as that mesh light can reach. So it's a sort of a combined effect to get this look right. And I'm going to go ahead and make all these other spheres into mesh lights as well. All right, now I've set up all those mesh lights. I'm going to hit render. And now you can see my whole scene is really lit up now from all of those mesh lights. Theoretically, if I really wanted to, I could make something much larger into a mesh light as well. Like this whole skull. I'm just going to really quickly hit mesh light. But here you can see, like with the spheres, that skull is now a light source. And we have to go through and change all the textures with it to make it look like it was actually a light source as well. But just so you can see the practicality of using other objects as light sources. However, note that because the skull has a lot more polygons, it's going to be a lot more resource intensive to use as a light source. So I'm going to hit stop in this render. I'm going to go over here. I'm just going to delete the light source on that skull. And for good measure, I'm going to clear the history. Next, I want to talk about skydome lights. And to create a skydome light, you just click this icon right here. It looks like a big dome. And what this does, it creates a sphere which projects light from all sides. So if we zoom out, we can see that our whole scene is encapsulated by this sphere. So this is really good for outdoor scenes to get a whole sky light going. And of course, you could, just like any other light, you can go in and change the color. You get orange. And hit render. And that's a pretty immediate way to light up your whole scene. However, you don't necessarily want to light up the whole scene from every direction the same way like this, because this isn't realistic to a sky at all. What we want is to have light coming in from, instead we want the light to be coming in from the sun. And it's fine to have some reflected light from different directions, but ultimately want to focus on one source of light. So the fastest way to get a realistic sky with the sun is to use an HDRI, and specifically one that is designed for a sky sphere. So HDRI stands for High Dynamic Range Image, and basically it contains more light information than a typical image would. So if you take a photograph and the sun is in it, the numbers to describe that white light from the sun go far higher than just regular white, which means that Maya can take that color information and determine how much brighter that sun is than anything else in the scene and use that as a light source. So with my skydome selected, I'm going to open the hypershade. And I'm going to press this button to open input and output connections for that skydome shape and press again. And from here, I'm going to press the little checker box next to color to create a render node. I'm going to select file, and the file I'm going to select is going to be in my source images. I've already grabbed a couple HDR images. I'm going to open that up. I'm going to grab this image. And so what that's done is it has stretched the image over my sphere. And as you can see, the sun right here in this image is acting as the primary light source for the entire scene. So if I hit render, now you can see all the shadows are coming in from that side of the scene. And you can tell by using this realistic HDR image, suddenly my scene feels a lot more real because of all of that real world color information that is being reflected in my scene from that HDRI. And then if say I don't really like what angle that sun is coming in at, I can select my sky sphere and then I can rotate it around. Then the sun is coming from that side. And play on the render. And so now everything is being illuminated from that new angle. There are a lot of free places to get HDRI images online. All you have to do is Google HDRI image. And also I will leave a couple links in the description to point you to a couple sites where you can find these images. But let's say you don't really want to use one of these images. You just want to have a realistic sky which you can adjust every little part of yourself. The other approach you could take is to create a physical sky. I'm going to go ahead and delete my sky dome. And the physical sky is this icon right here, 2 down from the sky dome light. I click it. It's not really giving me a preview. So I'm going to have to render it to see what it looks like. So the way a physical sky works in Arnold is it actually simulates a real sky with a sun and everything. And you can adjust all these different little settings to change the colors of the sky and the sun to your liking. It doesn't come in with any clouds or anything because it expects you to simulate them yourself. So it's a lot more work to get a physical sky to look good. But if you really want to start from scratch, this is the way you do it. So I can go in and I can change the sky tint. Change the color of the sun. The sun a lot bigger. And you can go in and change the elevation of the sun. So if you want to get really stylized and artistic with your sky, you could tweak all these values yourself to get a very unique look. However, there is a bit of a middle ground to be had here between going for a full physical sky and a HDR that just looks like a photograph. So what I'm going to do for my final scene is I'm going to delete my physical sky, bring back in the blank sky dome light, go to the hyper shade, and this time for my file, I'm going to use the other HDRI I have packaged in. And this is more of a abstract sky by itself that does have some clouds in it and a preset color. But it's a little bit more barren than the photograph I had before, as there's no ground or any features to it beyond the clouds. I got the light coming in from there. And in your file node, in the hypershade, I'm going to go down to color balance. And from here, I can adjust the color gain to make the colors look a lot more stylized. And from there, I could also adjust the exposure to make it a lot darker. Maybe I made it a little too dark, so I'm going to change the exposure back up to 1. Maybe 0.8. We still want to act as a light source. Play again. There's a lot of ways to play with it, so just tinker around with it for a while until you get a look that you like. As a final touch, I'm going to go and add another point light to the scene. I'm going to drag it over here. I'm just going to put that inside my structure here. Give it a nice intense color, like a bright red. Turn back exposure. And we'll do a preview with Arnold. All right. If you want to see your scene rendered from one of your other cameras, you can go up to this dropdown and select one of the other cameras from the menu. So I'm going to go to my Uber cam and see what my scene looks like from that perspective. I can even scrub through and jump to different shots in my scene to get an idea of how it's all looking. So now that our lighting is all set up, we are almost ready to start rendering, but there's a couple settings we want to take a look at before we actually start. So I'm going to go up here, click this button to open up my render settings, and working first from the common tab, the first thing I want to check is our image format. By default, set to EXR, which is very similar to an HRDI. It holds a lot more color information, but we don't really need that for our purposes. For now, let's just use PNGs. Next, down here at frame/animation ext, we want to select an option that has a pound sign in it. Ideally, we want to do name.poundsign.exe. And what that means is every file that gets saved when we render will be exported with a name, and then by default that name will be just the name of your scene file, and then there will be a number for what frame was being rendered, and then the extension, which in this case will be PNG. So by changing this to have a pound sign in the middle of the naming convention, that allows us to have multiple frames. Otherwise, we wouldn't be able to set up our render to render anything more than a single frame. If we want to change the name for our scene, we can give it a new name. And scrolling down, we want to go to our frame range and punch in the length of our animation. So my animation is 380 frames. Put in 380. And scrolling down even further, we want to go to image size. And by default, this will be set to HG_540. That's not what we typically want. We want something with a higher quality, higher resolution. So we would go to 1080. Then next we have the Arnold Renderer tab. And the most important thing to handle here is our sampling. So when you render images in Arnold, or any render engine really, the render engine will do multiple passes of rendering each part of the image. And with each pass, it will get better and better quality results. However, it takes more time to do each pass. And so this is what our sampling is defining how many passes Arnold will make for your image. And each of these sliders corresponds to a different component of the lighting that Arnold will focus on when rendering. So diffuse refers to light bounces where, say, the color of one object might bounce off and illuminate another object slightly. Specular refers to the actual reflective quality of a surface. So if you have something that's really metallic, kind of like a mirror, this would refer to that. Transmission refers to objects that are transparent, so you can see through them. And then SSS stands for subsurface scattering, which is the effect of something that is opaque, but some light passes through it, but it's really scattered. So it makes the object look kind of like it's glowing. So the best example you could give is if you shine a flashlight through your hand and you can see some of the light shining through it. That's the kind of light that you get from subsurface scattering. And volume indirect would be for effects like clouds or smoke, light that is passing through a volume of something. And then camera AA acts as a multiplier for all of these together. That's the really fast version of each of these. You don't need to worry too much about the specifics of these for now. All you really need to know is higher number equal higher quality image, and lower value will equal a grainier image. I know I don't have any transmission or subsurface scattering or volumes in my scene, so all I'm going to do is I'm going to turn up the diffuse and turn up the specular by 1. I'm going to turn up the camera AA by 1. I'll even turn these off because I know I'm not using them. Before you go through and render out your entire scene, it's a good idea to test out your different sampling levels just to see how long it will take to render one image with the sampling you've determined. So you can do that by letting your system render out an image and just letting it wait until this reaches 100%. And then I can see right here in the corner, it took 48 seconds to render that one image. So then if you multiply 48 by 380, that means it would take a little more than 18,000 seconds to render all of my frames, or 300 minutes, or 5 hours. So when you are rendering a long scene like this, you really need to plan ahead for how long it's going to take to render that entire scene. And if you're on a tight deadline, you might actually decide to lower your sample rate. And see, now that I lowered my samples to camera 2, diffuse 2, and specular 2, that took 7 seconds. Much shorter. I'm going to raise my camera back up to 3 just to see. And with camera at 3 and diffuse at 2 and specular at 2, that took 15 seconds to render, which would only take 95 minutes or about an hour and a half to render. So for the sake of this recording and completing it and just demonstrating in a timely manner, I'm going to go ahead and render at a resolution of 720, just because it makes my renders a lot quicker, down to 4 seconds. And the quality is still pretty all right. I may go back and render a higher quality version of this later, but sometimes it's even good to just do a lower resolution render if you want to kind of see how it's looking as a full scene. So now that my settings are all set up, I'm going to close everything here. And now I want to start rendering my whole scene. So to do that, I'm going to go up to here. I'm going to switch to the rendering menu set. And under render, I'm going to go down to render sequence. I'm going to hit the box next to it. And it's really important to select the box rather than just hitting render sequence right away, because I need to make sure that I'm using the Uber cam that I set up in the last video. Otherwise, it will render 380 frames just from this angle, and it won't get my camera moves that I wanted from before. And then once you're ready, you can hit render sequence and close. And this pop-up will come up showing you the progress of your render as each frame is rendered out. So this process takes quite a while if you have a longer scene. So it's best to step aside and just let the computer do its work and come back to it later. Once your image sequence has finished rendering, you can find all your images in your images folder, and then it may be under the name of your camera, which for me is my UberCam. And you'll find all of your images laid out in PNG format. After you've finished rendering out your frames, go ahead and open up After Effects, and then in a new project, go ahead and right-click here in your project window, go to Import, File, and then navigate to your Images folder in your Maya project, and then select the first frame in your rendered sequence, and then make sure that PNG sequence is checked. And then once you've made sure of that, go ahead and hit Import. And what that's done is it has brought in all of those frames as one continuous sequence. But before we render this out as a actual movie file, there's one thing we need to change. This came in as a 30 frames per second clip, whereas in Maya, this was 24 frames per second. So we need to change this. So go ahead and right click this, go to Interpret Footage, select Main, which will give you this pop-up. And then just right here, type in 24 frames per second. And then hit OK. Then from there, you're ready to drag the clip into the timeline. And go to Composition, Add to Adobe Media Encoder Queue. And then once Adobe Media Encoder pops up, go ahead and pick an appropriate encoding format. I like to use the YouTube formats because they're pretty high quality, but they're still appropriate for the web. I'm going to select YouTube 720 and drag that preset up to here. And then just go ahead and define a place to save this file to. I'm going to navigate to my project folder, and just to keep everything in the same place, I'm going to save it to my movies folder. And call it rendered clip. Hit save, press the green arrow to start rendering. And then at long last, we have the fully animated render of my scene. I'm not particularly happy with the grainy quality of this footage, so I would definitely go back and re-render it at a higher resolution with a higher sample rate. But for just seeing a preview what the clip would look like, this is a pretty good pass. And so with that, I wish you luck in your own renders, and I hope you have a good day.